Section 5.3 has to do with indirect proofs. These proofs are not like the two-column proofs. Hopefully you'll be pretty good at being contradiction. You're going to contradict what's said to you. So sometimes as teenagers you're really good about this. You seek to prove something wrong by taking the opposite stand. So that's what these proofs are all about. There's 3 steps to an indirect proof. The first is you assume that the conclusion is false. Okay, so what they're telling you is what you're trying to prove. You seek to prove just the opposite. Okay, show that this assumption leads to a contradiction of the hypothesis or some other fact, such as a definition, postulate, theorem, or corollary. And then point out that because the false conclusion leads to an incorrect statement, then the original conclusion must be true. It's actually way easier than what those 3 steps make it sound like. So the first thing we're going to do is practice step 1. So you're going to state the assumption that you would make to start an indirect proof for each statement. So if they say AB is not congruent to MN, then you're going to say AB, or not equal to, you're going to say AB is equal to MN. If you say triangle PQR is an isosceles triangle, you're going to say triangle PQR is not an isosceles triangle. So you're being argumentative. If you say x is less than 4, then you're going to say x is greater than or equal to 4, because those are the 2 situations that can exist if it's not less than 4. And then if I have this statement, if 9 is a factor of n, then 3 is a factor of n. This, the conclusion, is what you're wanting to contradict or what you're trying to prove. So you're going to say 3 is not a factor of n. So you're just being argumentative on these. So here's an example of an algebraic indirect proof. So the given is 2x minus 3 is greater than 7. If that's your given, then you know that's true. Okay, that has to be true in every situation. You're trying to prove that x is greater than 5. The way that you start it is being argumentative of what you're trying to prove. So you turn around and you say x has got to be less than or equal to 5, which is just the absolute opposite of what you're trying to prove. You make a table, plugging in values where x is less than or equal to 5. So 5, 4, and 3, I plug them in. I show that in each of these situations, it makes my given false. Okay, so this does not support that, and I cannot contradict that. So when x is less than or equal to 5, it contradicts the given. Therefore, I have to conclude that x is greater than 5. So that's your 3 steps for that. Look at this one. The given is 1 over 2y plus 4 is equal to 20. And I'm supposed to prove that y does not equal negative 2. So what do I start with? Y is equal to negative 2. Second step, I plug in negative 2, and I get 1 over 0, which is equal to empty set, which is not what it told me in the given. It told me that I had to get 20. So this contradicts the given. Therefore, y cannot equal negative 2. So you're proving that if you take the opposite of what you're trying to prove, it doesn't work. Here's a geometric proof. Okay, it tells me that L is not parallel to M, and then it says prove that angle 1 is not congruent to angle 3. So I'm going to assume that angle 1 is equal, it says not equal, not congruent. I'm going to assume that angle 1 is equal to angle 3. And if corresponding angles are congruent, which is what those are, then the lines are parallel. So if 1 is equal to 3, then L would have to be parallel to M, and that contradicts the given, which says they're not parallel. So therefore we can assume that angle 1 is not equal to angle 3. Here's another geometric proof. Okay, triangle JKL, and I have the side lengths of 5, 7, and 8. And I'm supposed to prove that angle K is greater than angle L. Now, angle K is opposite of 7, or actually I'm supposed to prove that it's less than, and angle 8 is opposite an 8. So I'm going to assume that angle K is greater than or equal to angle L. And by the side angle relationship, angle or line JL would have to be greater than JK. JL, 7, would have to be greater than JK, 8. That contradicts what I already know, which is JK is less than that. So therefore I know that this has to be true, because this is not true. So therefore it's not greater than or equal to, it's got to be less than, which is what I was trying to prove. All right, so there's not a whole lot there. So your homework is on page 258, 13 through 22 all.